Okay, everybody, welcome to this week's stream. Glad to see you guys here again. This week, we're going to switch gears a little bit. Let's see, last week we covered, kind of going through our series where we're working through different materials and such, and we're going to continue that series as well. But this week we're going to, switch gears a little bit and talk about Substance Painter and external rendering setup. So we get a lot of questions about being able to, export maps from Substance Painter, and how are they going to, how can I take those maps and then use those in different renderers? One that we get asked quite a bit about is V-Ray, for instance. And so what we're going to do, like I said today, is we're going to take a look at a couple different renderers. In particular, we're going to look at V-Ray. We're going to look at Mental Ray in the Mila material, and we're also going to take a look at Modo using Modo 10, and we're going to look at their physically based material as well as their new Unreal material. So one of the things that I just want to cover real quick is been working on the documentation within Substance Painter, and we have a new section here. Well, it's not new, it's been here for a while, but we're now really getting in here and starting to update this. And so here you'll see we've got some new options here. So Modo's been added, Mental Ray, V-Ray, and so on. And so if you want to take a look at these, if you go into, let's say, the V-Ray section here, you'll now get more documentation on basically everything that we've covered. And also here, what I want to point out is at the top, we've got this download example scene. So the scenes that we're using in today's stream, you can download these, and use them, check them out and things like that. But anyways, everything that we're going to be talking about, you'll be able to see that here in written form as well. So with that said, what we're going to do is start with Substance Painter, and the scene that we are going to be using is going to just be the sample scene. So if you go to File and you open Sample, you'll be able to open this preview sphere scene here. Just recently as well, let me just bring this over. Let me open up Substance Share for just a moment, because I got some requests for this as well. So if we come over to, let me try to remember where I put this. I think it was in Meshes. Yeah, here we go. So this sample scene here, of course, it comes with Substance Painter. You have that. But here on Substance Share, underneath Meshes and Showcase, we have this thumbnail creation scene. And it's using the same sphere, but it's just different. The UV layout and everything is different. So if you wanted to use this sphere, export the maps, and try to use it for testing purposes with external renders, you are running into a problem. So we updated, we got the correct FBX sample scene here. So if you look on Share, under Meshes, Showcase, you can find that here. And I just called it Substance Painter Sample Scene Mesh. So this is going to give you the mesh with the correct UV layout. Okay, so here we are in Painter, and like I said, we're going to be using this scene, and what we're going to go through is how I can export these textures. We're also going to take a look at being able to configure some of your own exports as well. So for different things, like for instance, when I was working on the Mental Ray setup, I had to make my own configuration. Same thing here with using Modo's physically based material. I had to make a configuration. It's one of my favorite aspects about Painter when it comes to exporting maps, because it's really great that we have all of these options and we can mix and match, we can pack channels, we can do, get converted maps, things that we didn't even work with here in Painter that allow us to get the correct outputs we need for numerous third-party renderers and such. And so we're going to cover that as well. Now, before we actually get into exporting textures, I think it would be really good to talk a little bit about the models themselves and export options. This is another question that I think comes in through our support forums a lot, and I think it'd be really great to cover that. So as an example, we're going to use, I'll use Modo and Maya as example. Those are the two 3D programs that I use. And so I'm going to use those as an example, but if you're using, 3ds Max or Blender or a different program, these concepts that I'm getting ready to cover are going to be the exact same. So you can use OBJ, but I recommend using FBX. I use that for just about everything. So what I want to cover is, let's just select a mesh here. And for this guy, let me see here. Give me just a second. I think Maya's froze up on me. It sure did. Hold on just a moment here. Yep. Let me, I'm just going to restart Maya here. I'm sorry about that. Looks like Maya is kind of acting up on me here. So let me just close that down and open it right back up. That's always fun, especially when you're right in the middle of a live demonstration. But okay, it's coming right up. And you can see here, I'm trying to bring it into the screen using dual monitors. And all right, come on here. Let's work with me. Okay. All right, so here we go. We finally got this going. Okay, so let me just open up a scene here real quick, and all my windows are huge. All right, so let me just grab my demo assets here. And I've got a little rendering section here. And then here again is the sphere FBX file, just what I was showing you that you can download from Substance Share. So we'll open this guy up. All right, and we'll fit into view. Okay, so like I said, one of the first things I want to cover is just a couple tips about how we can export models, and so that when we export our models, they're going to be working correctly for us. So one of the things about this is that I highly recommend is that whenever you're working, especially if you're going to be doing any baking and such, see things like this here with the scale, and here particular in Maya, the scale X, Y, and Z. This guy was actually scaled up, so we've got values here of 100, and then we also, you can see that if you're familiar with Maya, here in the channel box, there are some basically keyframes here on the X, Y, and Z rotate of the transform. And so what I like to do is just make sure I zero all this stuff out, before I bring this into Painter and before I start using it. So let's do this. Let's come over, let's select these channels here. And what I need to do is just right click. I'm going to break these connections here. That way I can actually work with these channels here. So then I'm going to come over here to modify, and I'm going to do a freeze transformations. And so what that's going to do, you can see it's going to set my scale X, Y, and Z to 1 and my rotate X, Y, and Z to 0. And so I highly recommend that you always have this everything zeroed out on your transforms. It works the same way in Modo. I can actually freeze that. I believe in 3ds Max it's just using an X form. Not 100% sure about Blender, but anyways, just the concept of being able to just freeze out those transforms. Okay, so we have this guy selected, and I'm not really going into materials too much, but what I want to talk about is how we export this. What are the FBX settings that we typically should use? And if we come over here to File, and I'm going to just export my selection here, instead of OBJ, I'm going to set this to FBX. And let's just kind of talk about a few of these settings here that are going to be good for Painter. So if I just scroll down here to my FBX file format, I want to make sure that right now my version is set to 2014, 2015, basically. The 2016, 2017 option, we don't support that yet inside of Painter. So if you export with 2016, I believe that'll open. It won't actually open in Painter. So make sure that you're at least on version 2015. So once you have that, we're set to come over the Geometry tab here and take a look at what we have. So what I'll typically use is these options that you see here. So we have smoothing groups and smooth mesh. I don't really need that for now, so we'll turn that off. And so what I want to talk about here is the smoothing groups. So where this really comes into play is when you're thinking about the tangent basis that you're going to use, okay? Because when we actually are baking in Painter, and let's just assume that we are going to be baking directly in Painter. You don't have to. You could use a different program if you want. If you're using XNormal, that's absolutely fine because you can import those maps into Painter as well. But however, I like to just cover the workflow for using Painter. So inside Painter, there's the option of the tangent basis, and what that's going to do is if Painter does not detect tangents, and notice here we have tangents and binormals here as an option. If the tangents are not embedded in the FBX file and you import that mesh into Painter, Painter will then just automatically use MIC-T tangent space for baking the normal map. And that's a really great option. And what that's going to do is if you then utilize, let's say, that object in a game engine such as UE4 or Unity 5, those engines are now both default to MIC-T as well. And so what you're going to get with that is a synced tangent basis workflow. And that's really important, and it's really good for working with normal maps. So in this case, let's just give the example of, say, hey, I'm going to want to export this. I'm going to texture in Painter, and I'm going to render inside UE4 or inside Unity. So what I would do is I would make sure that my tangents and binormals is unchecked. I don't want that. I'm going to let Painter compute the tangent using MIC-T. And I know that when I import into Unity or UE4, I'm also going to have the option to let those programs compute the tangent basis, and they are also going to be using MIC-T. So again, we get that synced workflow. So that's how that works in that regard. Now with that, we've got our smoothing groups. So if you could get away with using something, if you're in a synced workflow, you could get away with just using a single smoothing group. I would say probably most of the time. There are scenarios where you would have to use some hard edges, things like that. We're not going to get into all that inside this video. If you're kind of curious or not really sure exactly what I'm talking about, if you go over to our YouTube channel in our Substance Painter Texturing for Beginners, there's a whole section on model preparation. I think it's like 5 videos. And there's actually a video specific to tangents, and it covers all this in depth in terms of showing examples of using smoothing groups, using hard edges to control the normal map, how you have to use padding if you're using hard edges and things like that. So we won't get into that in this stream. But anyways, I just want to let you know that the information is there for you on our YouTube channel. So what I want to do though is talk about, in this case, in this kind of high-level case, we're looking at, a synced workflow, and we're going to have smoothing groups just for everything. We don't have to worry about it because we know that since the tangent basis is synced, it's going to basically, correct for all the, smoothing errors and things like that in the normal map, and would be good to go. So anyways, I just want to bring that to your attention. So you're always going to want to have smoothing groups enabled because, again, your mesh is going to have either all smoothing or it's going to have some hard edges and so on, but you want to make sure that you have that. And then Painter is going to utilize those smoothing groups when you import that in. Now, in our case, or in the case of talking about external renderers, let's say that we're using V-Ray or Mental Ray or Modo or something else, and we're not exactly sure what that tangent base is going to be. Like, I don't know personally the tangent basis that V-Ray is using, so I don't know if it's MIC-T or not. So in that case, what I could do is then say, okay, I need to export tangents and binormals in this file. All right, so I'm going to use my smoothing groups and my tangents and binormals here. And then I'm going to take this into Painter. Painter's going to see that tangents are embedded in this FBX file. And with that, it's then going to use the tangent and binormals embedded in the FBX file to bake the normal map. So then when I get back into Maya and I'm rendering with V-Ray, I'm going to use those tangents and binormals from the FBX again. So in a way, we still have that synced workflow. It's just a matter of, are we letting Painter and our 3D program or our game engine compute the normals, or are we using the tangents and binormals that are embedded in the FBX file? So it's just something to be aware of, when you work and such. And it really comes down to understanding the baker and the renderer, and you need to know, what tangent basis these guys are using. If they're not synced and they're using 2 different things, you're going to end up getting issues with your normal map. And when that happens, that's when you find yourself having to create like hard edges on models and to fix smoothing errors, and then you're having to split the UV shells and use padding in the UV and all this kind of stuff to control that. So anyways, just be sure that that sometimes you're going to need these tangents and sometimes you're not. It really depends on what the renderer and the baker are using. Are they in sync or are they not? If they're not in sync, then make sure that you export with tangents and binormals. Now, so we would have smoothing groups, tangents and binormals enabled. Now, triangulate's another option. So if we're going to be using this as the bake, I always recommend just making sure that you manually triangulate the mesh. Because when it depends on, and I guess this is more in terms of rendering with Game Engine actually, because when you're talking about doing something in real time that's going to be rendering on a GPU, like with Unreal Engine or say Unity or something like that, the mesh is going to have to be triangulated anyways, and so you get to that situation is, are you going to let, let's just say it was UE4 or Unity. Are you going to let the game engine, are you going to let the triangulation happen there, or are you going to let it, or are you going to control it manually? The thing is that, each program may triangulate the mesh differently. There might be a different winding order or something like that, and that can cause discrepancies with your normal map as well. So what you want to do is just make sure that in a real-time environment type situation that you want to triangulate. So make sure that you bake your normal with a triangulated mesh, and it's going to be the same triangulated mesh that's used in the rendering. Now for like offline rendering, that's not very critical, so we don't have to really worry about that because we can render with quads. So anyways, we have that set. And just want to bring your attention to basically, this section here. Let's do the same thing with Modo. So I'm going to open up Modo here. And let's say that, again, I have my mesh. This is the kind of setup that I use. So if I come over here to my system preferences, and let me bring the window here into view, and we'll come over here to FBX. Now, you'll notice here that, we have all these settings. So here's what I kind of change. And actually, I set my own up as well as a preset. So I'm going to have save geometry. We talked about triangulate geometry, when and you may or may not use that. So for here, actually, give me just a second. I'm getting a high CPU usage here, and that's because Modo's preview is going. So let me just pause that. All right, so obviously we want to save our geometry. Maybe we triangulate, maybe we don't. I don't ever have save cameras and lights on. Save materials, I do want to have that, because if you're working with Modo, anytime you create materials here in your shader tree, so material groups, with save materials enabled, those material groups are going to be translated into texture sets within Painter, so we're going to want that. Don't really need any of this stuff for right now. Don't need this. Do need my smoothing groups here, and here is our option for saving tangent basis. So similar to what we just talked about inside of Maya, same thing here within Modo. So let's turn off our animation. We don't really care about that. So again, save tangent. If I was using, Modo, and I'm going to, if I'm using Modo and as a model, I'm going to bring this into Painter, and then in the end, I'm going to work in, say, UE4, Unity, something like that, and I know that MIC-T is going to be used through the entire pipeline, then save tangent basis, we're going to leave that off. We're not going to worry about it. But there could be a situation where we do need to use that, and so on. So anyways, basically, same settings. Another thing that I do, export type, I usually set this to export selection, and I like to manually, select what I want to export, so that when I do file export as, I know that the export type is going to be set to selection. Something else I want to bring up here within Modo that's interesting is that here I'm in the Game Tools tab, and let me just come over here to Game Tools, and we'll come over here to our vertex map. So within Modo 10, we have the ability to create, different types of tangent, we have the ability to create a tangent basis here. So for instance, it'll show up here in our other maps, and I have one here. So let me just right click on this guy and delete it. And let's come over here and say, do we want to delete this? Yep, we do. All right, so mesh tangents, if I just click this button here, you can see that we now have the option to create MIC-T tangent basis, or source tangent, or the legacy. Now this is basically geared up for utilizing, for game engine type stuff. But if I wanted to basically save tangents inside the FBX, but I wanted them to use MIC-T, I could just enable this guy, and you'll notice here that under my other maps, I've now created basically a vertex map for that tangent basis. However, you don't have to do this on export. That's what I want to show. So anyways, we could do it if we wanted to, but again, we don't have to. If we don't have any tangent basis and we export, and we just make sure that we uncheck save tangent basis and then FBX, remember, we know that Painter is going to compute with that MIC-T, so we're just going to let Painter compute it. We know that Unity and UE4 are using it, so we'll let them compute it. However, third-party renderers, you may or may not, want to work with that. You may need to have that tangent basis embedded. So another thing that's interesting though about this, if we're using the Modo renderer, we could use MIC-T, so we know that it's again going to be synced all the way through there as well. Okay, so now let's jump here over to Maya again, and I'm going to open up a sample scene. So let me just fix all my windows here. So renderers, V-Ray, and we're going to look at V-Ray first. And we're going to talk about the setup. So let's go through, let's export some maps out of Painter, and let's get everything set up here. So let me just kind of get my windows all together. All right, and here's our V-Ray material. Okay, so let's jump back over to Painter, and let's say, I've been doing this work. I've got this amazing, sphere, this metal sphere here. It's, it's the best 3D work you've ever seen, and I'm ready to just, export this and render it inside of V-Ray. So what I'm going to right-click, and I'm going to export my textures. And you'll notice that underneath our configuration here, we've got, a bunch of these presets, and we actually have a V-Ray preset. And so, it's simple enough to use V-Ray. You're just going to use this preset. So here underneath my export here, I'm just go to my config, and I'll just come through and choose V-Ray. And that's basically it. That's all I got to do. But let's talk about this config so you can really see what's happening here. So underneath this config, you can see that, it's creating several of these output maps. So we've got diffuse, reflection, glossiness, IOR, normal, height, and emissive. So if we look at diffuse, here we can see that diffuse in this case is coming from this converted map section. So notice that it's kind of got this kind of gray box around the RGB, and you can kind of see that same kind of grayish box here around this diffuse converted map. That just is a visual indicator that this converted diffuse map is being used. So I want to bring this to your attention because by default, Substance Painter is working with PBR metallic roughness shader. But with Substance Painter 2, we've added the ability to now natively, or officially I'll say, work with specular gloss. So you could work with either one. Let's come over to our viewer settings, I believe it is. And yeah, here's our shader. So if I click this shader button, you can see that we've got, let's see, where is it here? PBR, that's the alpha blending. Here we go. So here's the PBR spec gloss. And when I enable this guy, and I come over here, let's just say I did enable it, and I go to my channels, you'd see that we would have channels like diffuse and glossiness and so on. So it depends on, are you going to use these converted maps or not? It depends on if you are natively using the spec gloss, shader, and you're working in that, which is totally fine to do, then you would probably have to change your configuration. So if we come over here to our configuration, let's say that we were using V-Ray and I used the native spec gloss workflow. Well, I wouldn't use this diffuse and glossiness converted maps. I would actually use my input maps because I've used the actual diffuse and glossiness inputs, and I've worked with those, and those are going to work. And so here you would see that I have diffuse and gloss and so on. So just something to be aware of if just what shader you're using. By default, I just wanted to point out that this preset is using the converted map. So basically, it assumes that you're using the default PBR Metal Rough shader. And what's nice about that, though, is that let's say that you are using PBR Metal Rough, and it's going to give you base color. It's going to be very specific, okay? So it's not really going to match, offline renderers at all, like V-Ray and things like that. So what you have the ability to do here in Painter is simply say, okay, well, I need an actual diffuse map. And this is still diffuse as in PBR data diffuse. And what I mean by that is just because it says diffuse, don't think about, okay, it's not PBR, it's traditional blend-fong type shaders that we used to work in. It's not. It's still talking about, physically based authored content. So what it means is that, let's say I have our base color in Metal Rough, and base color contains two pieces of information. It contains, it's going to contain your reflectance value that you're going to have for your metals. And so what you need to do with that, though, is realize that here with our diffuse, it's going to change. So basically, diffuse is going to have black basically for our dielectric or for our metal. So it's going to basically take that areas that are metal and it's going to, place those in as black. And then you're going to have all your non-metals, your dielectrics are going to have that diffuse reflected color. So you can see that that's going to be that kind of converted map from that. Now we also have another map type here called reflection, which you see here. And what I want to talk about with that is, what this reflection map is. And it's just, it's basically going to take maps from this PBR workflow being metal rough, or in our case, specular gloss. It's going to take those and it's going to convert that data so that we can use it for renderers that would take a reflection map, such as a V-Ray, or in my case, I used it inside of, I believe, Mental Ray and Modo as well. So what this map does is it basically represents reflection color. And that means that if you're using non-metal, like let's just say that, this was a complete dielectric, there's no metal, that map is going to export just pure white. And sometimes on our forums, we've gotten support requests asking about that. Like, hey, I exported this reflection map and it's pure white. And why is that? Well, the reason why that is we just kind of think a little bit on how these offline renderers are working. And most of the time with these guys, the Fresnel and specular color, they're separated. So they're used as separate controls. Basically, if we think about Fresnel, it's reflection intensity that's based on the camera surface normal angle. And you can control this using the F0, which is basically the IOR, index of refraction for that material. And with that, that's why the dielectrics, we set these to a reflection value of 1, because all materials, when we're talking about, physically based authored type content, all these materials are going to be 100% reflective at this grazing angle. So for the dielectric, your reflection map here is going to end up being like pure white. And that's why you would get that in that case. Here we have our gloss. And let's see here. You'll notice, so we're using here our gloss. Notice that we have this other gloss type over here, glossiness squared. We'll talk about that later. But in this case, we're just using the glossiness map itself. Now here, we actually have this IOR map. And so if we look at this, it's using, for converted maps, you can see it's 1 over IOR. And so what I want to talk about is what that map is, in a sense. And we're actually going to look at what these maps look like once we get into Maya as well. So the thing is with IOR is that, we want this to be always greater than 1, for the materials that we're working with here. But we don't want to use like a floating point, like an HDR image that's going to allow us to take values above 1. So, if we have just like an RGB map, it's, if we're looking at it as float data, it's going to go from 0 to 1, but it's not, since it's not HDR, it's not, or 32-bit, it's not going to go over 1 in that value. So we get that kind of problem there. I was like, well, wait a minute, the IOR value needs to represent, greater than 1. So the reason why we have this is because, some renders in like such as V-Ray will interpret this, values less than 1 as 1 divided by, we'll say X or whatever. And so what you end up getting here, let me just open up my calculator so we can just see what I'm talking about here. And no, we're definitely not getting ready to get into a bunch of math at all. But anyways, I just kind of wanted to show you that. So let's just say that, now we're thinking about our map in terms of, 0 to 1. So we're not talking about like HDR data at all to represent our IOR. And I don't mean HDR would represent, I just mean that, values greater than 1 with that. So here you would say, like, what if we had like something like 0.5, which is going to represent, an IOR value, which this doesn't really have a physical meaning for us. So V-Ray will interpret this as 1 divided by 0.5, and that's what I meant by 1 divided by X. So let's just do that so you can see what it is. So 1 divided by 0.5 would equal 2. So there's where we're going to get our IOR value of 2. And this 1 over IOR is just simply allowing us to use a texture to control the IOR over the surface. So that's what that map is actually doing, and you'll see that it's very good map to utilize. Now, when we talk about F0 here is another map, and we're going to use that inside of when we take a look at using physically based materials inside of Modo. So I want to talk about that a little bit. And this F0 map is actually used inside of Arnold. So if we come over here to our Arnold preset, notice here that it's using F0. So diffuse, spec, rough, and F0. You'll notice that as you go to all these different renders, like, okay, we're at Arnold and it's using, diffuse, spec, rough. V-Ray, it's using diffuse, reflection, gloss, IOR. So you have all these different options, but within Painter, we give you the input and converted map types that allow you to configure this to fit the renderer that you're using. So like I said, Arnold's using this F0 value. And what this does is it's just reflectance value for F0. All right. So in terms of PBR, the F0 for dielectrics is going to be 4% reflected. So it's, if we look at that in linear, it's going to be 0.04. And for a metallic value, which is, we want this to go up towards 100% reflective in that case. So for the metallic areas of your asset here, it would be 1. So it's either going to be 0.04. You'll get looks like a really, really dark gray. So 0.04. Again, we're talking linear value there, which represents 4% reflectance. And then it's going to go to 1. So it's either going to be a really, really dark gray or a white. And again, we'll take a look at that when we get into Maya. So that's what that F0 is doing. All right, so just a quick lesson here on the configuration and what these particular map types are doing. It'll make a lot more sense when we start looking at this from a practical standpoint, which we're going to do now. So here's what I would do. I'm done texturing, and I want to come over here, and I want to choose V-Ray. So now that I have this set up, I would just export my textures. And then I'm ready to jump over to Maya. So I already have these guys exported. So let's do that. Let's just jump into Maya and let's hook this guy up. So here we are. And let me just minimize that view there. And so here's our V-Ray material. So let's do this. Let's just right click and we're going to create a node here. And my node editor is way over here. And let's just do this from scratch. So where are we here? Surface V-Ray material. So let's grab this guy. All right, so we have our V-Ray material, and I'm just going to middle mouse click and drag this here onto my mesh. And let's do this. Let's go to renderer, and I'm going to try this. Let's use the V-Ray IPR, and let's see if this isn't going to freak out my CPU usage here. Hopefully not. Okay, so here we go. Let's experiment with this. Okay, so how do we hook this up? All right, well, first thing that we want to do here, let's do this so we can really see what's happening here. Let me just copy my maps here. So let me just copy these guys. And I'm just going to paste them here. Where did they get pasted? I think I have it set to where it's not showing new nodes here in the graph. Okay, never mind. We won't worry about it for now. Okay, so let's grab this guy. Let's come over here to our textures here. And in this way, we can kind of start see they're all getting pasted in here, but they're not showing up into my graph. Oh, well. Okay, that's fine. So we'll come in here. Maybe I could rearrange my nodes. All right, that's fine. Okay, so like I said, here's what these maps look like here. So we've got our diffuse, gloss, IOR. Remember I was talking about that IOR, and it almost looks like a metallic map, but remember, don't get it confused there. It's not a metallic map. It's basically the white areas are going to be 1 in the map, so 1.0 white, and they're going to represent metal. And then these dark areas are actually, they're going to look dark, black, but they're not black. It's 0, remember, it's 0.04, so it represents 4%, and that's going to be the F0 value for dielectrics. Okay, so here's our diffuse color. Let's grab our diffuse map, and I'm just going to middle mouse click and drag and place him here. Okay, so here's what we're getting. So that's in my basic parameters here. And okay, just a question that came in here. What does the document channels export setup do? That's a good question. Let's just address that. Actually, I'll tell you what. I'm going to address that when I get into showing how that works in Modo. So all that does is it just exports the document channels you have in Substance Painter. So basically, in your texture set settings, whatever channels you have set up, it's just exporting those channels. So that's why we call it the document channels. Okay, so we got our material. We put in our diffuse here. And the next thing that we're going to do is take a look here at our reflection here. So for the BRDF type, we want to change this from blend here to, sorry, not Phong, GGX. So we want to make sure that our BRDF type is GGX here for our V-Ray material. And I believe that that is available in V-Ray 3.1 and higher. I think what I'm using here is, I'm using V-Ray for it's actually just the trial. I think it's 3.4 is what I'm using. Okay, and then here underneath our reflection, we want to uncheck this option here called Lock Fresnel IOR to Refraction. So we're going to uncheck that because we want to be able to work with this Fresnel IOR value. All right, so now let's take a look at our reflection color. So here's the map that we're going to use. And let's see here. Let me just bring this guy up. And we'll do a view. And here's this map. So notice here, this is our reflection map. And so you recall earlier when I said that what the reflection map does is it's going to export basically a white value for dielectrics, and then whatever metal, whatever area is indicated as metal by the metal map, it's going to actually use that metal reflectance value that you've chosen. So if you think about this in terms of, I'm in Painter and I'm using the metal rough workflow, so I'm going to have a base color map. It's basically just going to take the base color and just place it in here. So notice we got white, pure white. That's what the reflected color would be for dielectrics. We don't want to tint that. We want that reflection color to be white. So that's why that map shows up as white. And then in metals, of course, they do have tinted color values like that. So that's why we have a color here that represents that metal reflectance value. All right, so we'll pull this over. Let's grab our V-Ray material once more, and here's our reflection value. So let's just middle mouse, click and drag, and place that here into the reflectant. The reflection color. And so now you can see we're starting to get some reflection happening here. So the next thing that we want to work with here is our reflection glossiness. And so here we have our glossiness map. We can use this basically, I'll say 1-to-1, because here in V-Ray we have the ability to set the BRDF to GGX. And that's what we're using inside of Painter, so it works great. So middle mouse, click and drag, reflection color. Okay, so now that we have that set, we need to really start to work with the actual Fresnel, the IOR value that we were talking about before. And so here, if we take a look at this map, so here I should be able to just select and say View. Let's look at this map here. We bring this guy over. And so here's what we have. At first glance, like I said, this is going to look like a metal map, but it's not. If you sample this dark value range in here, this is what I'm talking about. This is actually not black. It's not 0. It's actually 0.04. And again, that just represents 4% reflectance range. So it's like the F0 for dielectrics. And then here you can see that we've got this white area here. And in this case, this could be, if this was a raw metal, you would see this as pure white. However, in this case, it's not. It's just a little bit darker here. So because in this particular guy, here, let's do this. Let's jump over here to Painter. And let me flip through my channel. So hitting C on the keyboard, I'm at base color, height, rough, and here's metal. This metal here is actually, it's not 100% metal. It's kind of hard to see here within the viewport, but it's not 100% metal in this case. So when we jump back over here to Maya, and let's view that map again, here's what we're getting. All right, so now we need to hook this guy in. So let's go back to our V-Ray material, middle mouse, click and drag into Fresnel IOR. And when we do that, boom, we get our render. We're done. So really simple setup here. Well, you know what? One thing we forgot to do was our bump mapping. So here, bump and normal mapping. Let's switch this guy here to normal and tangent space. And let's see here. There is my normal map. Actually, I already have this guy, so here's my normal map. Let's do this. Let's just middle mouse and drag and drop him right here into the map slot. And so here you can see it's starting to render. I just stamped in these little these little normals, kind of screw heads basically here into the side just so I could see some normal here. Okay, so notice I'm working in Maya, so that's one thing to think about. In Maya, the normal needs to be OpenGL, and so if I just switch back over here to Painter just for a moment, let me right-click, Export Textures, Configuration, V-Ray. I've set this up to use the normal OGL. I think by default of what we have in our export documentation, I think it's just using the normal, which is going to be DirectX. So we need to switch that basically. So just so you know, in Maya, the normal needs to be OpenGL, and that's what I'm using here. So all I did in this case was I just went over here and I just grabbed the OpenGL converted map, just left click, drag and drop it right here on this RGB, let go of my mouse, RGB channels, and then it sets it. So Painter, again, that's what's awesome about these converted maps. Painter can do these types of conversions and things like that for you. Okay, so another question that came in here that's really good. How do you convert gloss values between BRDFs? Is it possible to do this in Substance Painter? Yeah, it is, and that's actually what this glossiness squared map is going to be. We'll cover that in just a moment when we get over to this mental ray section. But yeah, it's a tricky thing, and it's not you know, don't want to say the word hack, but it kind of is. It's not a real easy thing to do. You know, it's not what I mean. It's easy. I mean, you'll see the setup that we do to do it. It's nothing difficult, but it's hard to do a perfect conversion so that it looks, oh, it's perfectly the same thing. It just doesn't work that way. So you can, basically remap the value so that maybe it looks close enough. But yeah, that's kind of what we have here with this glossiness squared map, and I'll get into more about that. And actually in Maya, you'll see how I set that up manually. Okay, so let me just cancel that and jump over here back to Maya. And so there you go. There's our V-Ray setup. Couple things that we need to discuss though, and with physically based rendering, and physically based rendering has been around long before it started showing up for games. There's been physically plausible renderers, in film for a very, very, very long time. And so only now are we starting to see this in things like Substance Painter, Unreal Engine, Unity 5, things like that. And it's new to the games industry, but it's definitely not new to film. And so linear rendering and workflows like that have been there for ages. And so with that, though, and with physically based rendering in the sense of how we're working with this here inside of V-Ray, we are working in a linear workflow. And what that means is that we need to make sure that we, flag our maps correctly. Now, we're not going to get into a huge discussion over linear workflow or anything like that, but I do want to just bring to your attention, what that means in terms of how do we set our maps correctly. And it's actually real simple. The simple rule to get that to work. So we've got our maps in here, but we need to make sure that these maps are being interpreted correctly. So let's do this. Let's come over here to our diffuse. Okay, so I select it, and then here in the material viewer, you can see that for my color space, it's set to sRGB. Perfect, that's what it needs to be. I think it defaults to sRGB for everything. So sRGB, perfect. Okay, so basically, we're gonna have to deal with some gamma correction with this. And what we're saying to this is, hey, this is color that we see, basically. So anytime you see a map that represents color that's reflected back to your eye that you see, I like to say, I don't know, if you think about an apple and the skin of a red apple, okay, so I look at that apple like it's reflected back to my eye, and it's red, so that's color that I see. Anytime you have reflected light back to your eye, that map needs to be flagged as sRGB. That's going to be things like diffuse, and it's also going to be, where is it? Reflection. So if I select my reflection map here, again, reflected color is what that is representing. Notice again, color space is set to sRGB. Okay, so again, rule of thumb, if it's reflected color that you can see being reflection color or diffuse reflected color, like, maybe the color of a wood surface, or like I said, the red skin of an apple, something like that, sRGB. Now, what about the other maps like IOR and glossiness and things like that? Let's look at those guys. Let's do glossiness. So this map was authored in gamma space. You know, we always author our maps in gamma space. You know, that's the way our eyes kind of see basically in a gamma corrected space, our monitors that way. You would never want to author your maps in a linear space because, you know, you'd never really know how you're picking the values correctly. It just doesn't work that way. But we do need to tell the system in a linear kind of workflow, and Maya is kind of handling this color correction for us behind the scenes. So it's awesome. We don't have to worry about it. But we do have to make sure that we flag the maps correctly. So like I said, by default, when this comes in glossiness, the color space is set to sRGB. So if I do this, if I set this back to sRGB, and our update here should, well, it should update, hopefully. Let's see here. There we go. So what this is going to do is it's then going to, here, let me get this guy selected. It's going to get, basically it's going to look more glossy than it should, because, you know, what we need to do is say, hey, look, this isn't, we need to work with these values as data. Okay, that's the best way I like to look at it. This doesn't, you know, these values represent data. Yes, they were, you know, created in a gamma space, basically, if you want to think of it that way. But, you know, these values that I picked were specifically to represent a data range. So that's why we need to come over to Maya and we say, hey, glossiness, it's not color that I see, it represents actual data, so its color space needs to be set to raw. And so when we do that, we're basically, behind the scenes, what happens is the shader is going to, what I like to say, linearize the image. So it's just going to apply an inverse gamma to that. So if we're using 2.2 as our gamma, it's going to be, you know, 0.4545, the inverse of 2.2, and it's going to basically strip out that gamma encoded values, and it's going to do that so that it will render correctly in linear space. So a lot of explanation to that, but don't worry about it if that doesn't make any sense whatsoever. If you want to know more about it, we actually have information in our PBR guide, which you can download for free on our website. You can look at it. Probably volume 1, I think, covers linear rendering from like a more of like a theory level, and then, you know, volume 2 discusses it somewhat. But check out volume 1. I think it's in there. There's a section on that. So the big thing to take away from that is if it's data, set it to raw. If it's color that we see, like diffuse, then set it to sRGB. So our IOR, obviously, that represents data. That guy needs to be set to raw. Here again, if I set this back to sRGB, you should really see a difference here in our viewport. Let's see if I can get this guy to update. Yeah, it's not updating correctly. It's all right. So anyways, like I said, it's good. If you have these interpreted incorrectly, when you look at it, you're going to get a pretty drastic difference to what you saw in the painter viewport, and sometimes that's a clue. So if you see, like, if you have your gloss map and basically it looks oh, this looks a lot more shiny or glossy than it did in painter, that can be like a cue of thinking, oh, you know what, I probably forgot to change the color space. I do that like every single time I hook up my textures. So anyways, you'll notice that. So like I said, data, raw, reflected color, sRGB. Okay, one last thing we'll cover here. Let's just hit this guy to bring open our, and I keep having trouble with this. Let's see, there we go. And just toggle back and forth and everything will load. Under color mapping, this is how I have things set up here for V-Ray. So the color mapping section here, set this to linear multiply, and for the gamma, I set this to a value of 1. And then if we come over here to the V-Ray frame buffer, let me set my renderer back to viewport 2, and let me just hit this with a quick render. I had this issue too here. Let me see if it'll show back up in a second. Probably won't. Here, let me see if I can just cancel. All right, where's my frame buffer window? Let me see if I can find this guy. Nope. I don't know. I'm having some weird issue here with the... There it is. Gosh, these double monitor, two monitor thing is acting weird. All right. So, anyways, like I said, let's bring this guy back up. And so what I had here was my gamma set to 1. Now here in the V-Ray frame buffer, we actually have this option enabled, which is display colors in sRGB space. So with linear rendering, basically, you know, all the incoming maps are linearized, basically. So, and I think I may have explained that to you wrong when I said the IOR. Actually, I wasn't thinking correctly here. things like IOR and glossiness, when we set those to raw, they're not getting linearized internally. What's actually getting linearized internally is those diffuse and reflection colors. So basically what you're saying to the system by flagging this as raw is you're saying, hey, assume this to be in linear space already. And the shader's not going to do any gamma correction stuff to it. It's only going to do the gamma correction to things like what you flag as sRGB. And that's when it's going to do that inverse gamma, 0.45, 0.45, reverse, remove the gamma out, do all the rendering calculations, and then when everything comes back in the render, the overall render itself is then gamma corrected and on top. And that's why we have this option here for display colors in linear space. So the calculations happen in linear space, which is correct. We need it to happen in linear space, but then we can't really see that very well, so that's why it gets gamma corrected on top. Now, here's what it looks like if we don't do that gamma correction on top. We just turn this switch off, and so everything just looks like super dark. So this is linear space. We're viewing the data in linear now, all right? And so it's skewed because, this isn't the way our eyes work, and this isn't the way our computer monitors work. But it's the correct math for generating these images. So that's why we have our gamma set to 1, and then we'll come over here to this guy, and we're just going to display them in sRGB space. So we gamma corrected the render on top. At the end of the pipeline, everything comes out looking good. And you'll notice this looks almost identical to the Substance Painter viewport. So hooray for V-Ray. It works really well. The V-Ray shader is awesome in this case. So now let's switch gears and take a look at the Mental Ray version. So open this guy up and let's graph our network here. Okay, and so we're going to work with this guy. Okay, so with Mental Ray, this is something that comes up as well. We get questions about, hey, can we work with Mental Ray? Yes, you can. It's not a perfect solution. You can do it, and I'm going to show you how it works. But the problem that we have right now with this is that with the Mental Ray shader, and what we're using is this new well, it's not new, but it's it's the Mila shader or Mila shader. I don't even know the right way to pronounce it, so I'll just say the Mila shader. And this is a really awesome shader or material here that Mental Ray provides. It's actually coming from the MDL material definition language kind of setup that NVIDIA is working with iRay. But what this allows you to do is basically create layers for your material, and I'll show you how that works. So you can layer different glossy Fresnel reflections on top of each other to create all kinds of different materials, from what we're going to do here. Maybe it's a car paint material and so on. It's really cool that you can layer these together. Now, one of the gotchas that we have with this, though, is that the Mental Ray does not yet work with the GGX BRDF. So we're going to have a problem with that, and it's going to be hard for us to match what we're getting inside of the the Substance Painter viewport, because if the BRDF like that if it's just mismatched, it's never going to look right, and it's going to be hard to approximate it. But I'll show you what we can do to kind of get it close enough, but it's not really working that way. So with that, a couple caveats. Let's do this. Let's go to Create Node, and I want to tell you one thing that I think is pretty cool. If we come over here to Mental Ray Materials, they now have this new MDL material. So let's bring this guy in. Now, the workflow with Mental Ray is going to get really cool in the future. As of right now, like I said, the Mila material is super powerful. You can create amazing materials with it. It's just kind of a complex setup, like you'll see. But with the MDL material, though, you could do something like this. So MDL module, if we come over, oh, look, we have our algorithmic materials here. Now, Substance Designer and Substance Painter's materials are built on the material definition language from NVIDIA. And we've been doing that since we've integrated iRay into both Painter and Designer. This is going to lead to some really nice crossover between Mental Ray and iRay and so on. So if we come over here to this Mental Ray module, I could choose something like, say, my AGL materials metallic roughness. And so when I do that, you can see that here's my material. And if I look at the properties, check this out. I get base color, I get metal, rough, all these things, my specular, basically everything that you have inside of Substance Painter and Designer. Here, let's really take a look at this really quick. If I just open up Designer, I'll bring that guy over here in just a sec. He's opening up. This is basically the same MDL that we're using inside of Designer. So here, let's grab this guy. Let's bring him over here. And let me just create a blank substance just so I can get something here in my 3D view. So for materials, default, definitions, here's what we're talking about here. So if I were to set this guy into iRay, materials, definitions, here they are. So that's what we're working with here. And we get the same values. So that's showing up here inside of my Mental Ray for free. It's awesome. But it doesn't work yet. So that's the gotcha with that. The reason it doesn't work is because the MDL version that we use is version 1.3, which is using GGX BRDF. And the version that's here inside of Mental Ray is still 1.1, which does not support GGX. So that's why we have everything. We can see our channels, but see how it's just rendering pink here? I apply this guy to my mesh. I could set up all the maps. It's still going to render pink. It's just going to be broken. It's not going to work. So anyways, in the future, this will work, but for right now, it won't. In the future, when it does work, it'll be as simple as applying the MDL, just export your base metal rough maps out of Designer or Painter, plug them in, and you're ready to roll. And you're going to get, the same result as you would in those apps. So it's going to be super easy. And if you're a Maya user, you don't have to have a third-party render. It's going to be built in. So it's cool, but not there yet. So what is here is our Mila material. So let's take a look at this guy. All right, so I'm going to show you how to set this up. All right, let's start this guy from scratch here. So let's just right-click and let's create a node, and let's come over here to materials, not MDL, almost did it again. Mila material, however you say that. All right, and middle mouse, click and drag, and place him on here. I'm also going to just quickly run my IPR here. Let's see if we can get this to work without a lot of trouble. All right, let's see what we can do here. Whoops. I'm sorry, I keep dragging out a region there. Let's see, what am I doing here? Yeah, I should be able to just do that. I don't think it's catching up here for my region. Yeah, I might be doing something completely wrong here. This was working, but then again, once I have the streaming software version running, it starts killing my CPU, and things start acting really weird. Yeah, CPU usage is really high. Let's do this. Let's not do the IPR for now. Oh, see, there it goes. It just caught up. Sorry, guys. Let's not do that. I think it's going to end up dropping frames and making the stream bad. I think we can use this little preview window here to get some of what we're doing here. All right, so the first thing that we're going to want to do with this guy, you'll notice that we have our base component here. So let's come over here to our textures, and let's look at what I'm actually going to output. So let's run over here to Painter. Let's right-click. Export our textures, configuration, and let's look at this Mental Ray configuration that I built. So yeah, like what I did, I just hit the plus button and just started, creating output maps and assigning, my maps so that I could build this texture export preset. That's all I did. And so what I'm using here is my normal, my roughness here. I'm using actual roughness map. I'm using a metallic map. I'm using reflection. So here again, that's going to be this guy right here. So it's a converted map reflection. And then I'm using diffuse. So diffuse, reflect, metal, rough, and normal. And then here I am using, okay, notice that for my normal, I'm using the OpenGL converted version of that as well. All right, so if we jump back over here and we take a look at what we have, let's start hooking these guys up. All right, so we got our textures. Let's put our diffuse in here. So we're just going to drag, middle mouse click and drag, and put him here into our diffuse. So here's what we have. All right, that was easy enough. Okay, so the next thing that we're going to want to do is now we're going to add a layer onto this. So I'm going to click the plus layer button, and I'm going to choose this Fresnel layer, and I'm going to choose glossy reflection. All right, so now we're going to have a glossy reflection. And here you can see in our little preview sphere that it's already showing up as a glossy reflection. And what I'm going to do is work on the metal first. Now, the issue with the Mila shader is that, you know, if you look at Substance Painter and what we're exporting, the shader and the materials that we're working with, they contain information for both dielectric and metal together, okay, in all the maps. So, but we don't have a way to really work with that within the Mila shader here within Mental Ray. So that's why we're going to use these layers, and then we're going to basically combine the layers with the mask. So that's what we're kind of doing here. So first things first, let's work with our metallic. So what I'm going to do is I'm going to set here my Fresnel IOR to something like super high. I'm going to set it to 50. Okay, and so you can see here in our preview, this is starting to look like, you know, once it starts to generate here, it'll start to look kind of like a metallic kind of look. Now, this value of 50 IOR, I actually got this from Zap Anderson, who's one of the guys that works on Mental Ray, and he's on his blogs. If you check out Elemental Ray or his blog itself, just look his name up. It's Zap Anderson. Here, let me just type that here in the comments, just in case you guys have not heard of him. There it is. This is where I got his value from. He has a nice blog post on you know, creating metal in Mental Ray, and that's where I got this Fresnel value from him. All right, so now that we have this set up and we're trying to work with a metal, we need to set our color. And so we could do that. So for instance, let's say that I select this color range, and this is a tinted metal value. So let's say that I tried to choose something like, say, this. You know, here you can see what we're getting in the preview is that, okay, it's starting to look like this somewhat metallic look here. But we actually have a map for this, and that's our reflection map, and that's what we want to use. So middle mouse, click and drag, place him in the reflection color. And so here's what we're getting here. So next, what we're going to want to do is mask this guy here. So that's why we have this weight value. And so with that, we want to basically use our metal map. That's why I exported out a metallic map. So again, metallic, everywhere that's white is going to be metal, and everywhere that's, you know, black is going to represent non-metal, and any transitional gray values in between is, well, it's going to be a mix of the two. So let's take our metallic, middle mouse click and drag, and place him here for our weight. And so now you can see that that's just basically masking out our metal material, and that's pretty much done. We also have our bump map. So our normal map needs to be placed in here. And let's see, where do I have my normal map? Here it is. So notice what I did here is I've got my normal, and I've got a bump 2D node set to tangent space normals. And so since I already have that, I'm just going to use that guy. So let's go back here to this material that I'm working on. I'm going to take that bump 2D node, middle mouse, click and drag, and place him here on the bump. All right, so that's that layer done. So next up, we also want to work on our roughness. Sorry, it wasn't done yet. So roughness, if we were to set this all the way to 0, which is black, basically, it's, you know, we get super shiny looking thing, and then, you know, we pull this up towards 1, we get super rough, diffuse, you know, reflection here. So we have a really nice map to help us with that, and that is our roughness map. Now, as I said before, and this was a question that came up earlier, you know, what happens when, you know, we have a gloss curve, a GGX gloss curve, represented in a map, but we're using a different, you know, BRDF. So in our case here in Mila, we're not using GGX. We need to be able to kind of remap or try to convert this in some way. And we're doing that here in Painter. So if I open this up and I right-click Export Textures and go to my configuration, you can see that we're actually doing that here with this glossiness squared. And what this is just the gloss multiplied over itself, and that's where we get the square. So it's just, you know, multiplied over itself. And what this again is doing is it's mapped the GGX gloss curve to like a blend Phong glossiness. You know, it gives you like an approximation. It's close enough. You know, and it avoids the use of trying to go in and remap a very complex curve. Now you could do that. You could use like a remap node and try to, you know, remap that here in Maya with your own curve and so on. And you could do that if you wanted to try to get even more precise. But kind of what we found, just ease of use, trying to get the easiest way to handle this is just, square the map, and it gets you close, basically. So if we go back over here to Maya, we're going to do that. All right, so let me show you how I actually do that. So if I come over here to Maya, here's what I do. So here's my gloss guy. Let me just move this guy down. We're going to do it from scratch. So this was just my map here. Now again, I'm going to select my map, just like we talked about with V-Ray. This is going to represent data, so we need to make sure that its color space is set to raw. So now that I have that, I'm going to right click and I'm going to create a node. Now, like I said, if I wanted to, I could do like a ramp. So if I wanted to do like a ramp, and I could input this into like the V chord of the ramp, and I could actually plot, a graph, and make a complex curve to try to remap this and get it to fit, even closer if I wanted to. In this case, I'm just not doing that. So what I'm doing, again, kind of like a hack, but close range is what we're talking about here. I'm going to use the multiply and divide node. Yeah, the question that just came in here, rough times rough. Yeah, we're doing the same thing. So when I have gloss times gloss, like gloss squared out of Painter, we're doing the same thing here inside of Maya. So it's rough times rough. In glossiness, when we look at this in terms of Substance Painter, and let's say I'm just going in and I'm looking at my roughness map, we're looking at the same data. Okay, it's representing the same thing. The roughness map and the glossiness map are the same. The difference is that they're just an invert of each other. It's just a different way of representing the same data. So, roughness is basically black is equal to smooth and white is equal to rough. Gloss is black is equal to rough and white is equal to smooth. It's just different implementations is all it is. So we're just doing the same thing is all we're doing there. So if we bring this guy back here into Maya, and like I said, we've got our multiply and divide node. And so I'm going to take my out color and just plug it here into input 1. And then for the divide here, I could just set this to 2. So just get that multiplication there. And then I'm going to output here my output X value. So if we look at our layers, and one of the things I find confusing about this is just the way it works. Basically, we're computing here, like base is the bottom, here is our glossy reflection, and then this is layer 1 basically, and then we have another layer on top. But it just numbers them kind of strange, I think. So if we look at this guy, layer 0 is like our topmost layer, I think, right now. I don't know. We'll see it when we add the next one. It's like always, I keep getting confused with it. It's like always backwards. But anyways, here's where we have our glossy reflection, and we just want to map this roughness here. So that's why I'm going to take just this output X and just plug it right there into the roughness. And that's all I got to do. So if we go back to our material, you can see that we've now input that map in. Okay, so that finally does take care of the metal section of this. Now we've done metal, we need to add the dielectric part. Now here's one of the things that's cool. Is that, if we were just doing like a full metal, we could be done here. Or if you have something that's just full dielectric, you can be done. You don't always have to have the 2 layers. The reason why we're doing this is because I wanted to have a more complex example where this object has both metal and non-metal, elements to it. And I think it's better to showcase that than just saying, hey, look, this was full metal and you just do this and you're done. So here, we're going to add a layer on top of this guy. And again, we're going to do a Fresnel layer. Glossy reflection. And here for the IOR, we're going to set this to 1.5. This is going to be an IOR that represents our dielectrics. This is the same. You'll notice, like, if you go into like other rendering applications, some of them default at 1.2, some of them default at 1.5. I was just looking at KeyShot earlier, and they defaulted to 1.5. In iRay, we default to 1.5 within Painter and Designer, so I'm just using 1.5 here. Okay, so now what we need to do, same thing here. Let's see. Everybody, it's getting messy in here. Let's see if I can just frame this guy up. What were these guys doing out here? Oh, that was that MDL material. Okay, so now you'll notice that we've got basically glossy reflection 4. That's the one that we already did. Here's a new one, glossy reflection 5. And this is what I was talking about that's weird. Layer 0, notice it doesn't have a weight applied to it. So when you look at this guy, when you look at how the layering's working, layer 0 is always the top. So every time you add a new layer, it's basically, you know, it's going to add, it's pushing everything down. To me, that's just, that doesn't make much sense. Like that's why I keep getting confused. I look at this and I think, oh, this should be layer 0, this should be layer 1, that should be layer 2. So it's driving me nuts. But the new one we just added is now layer 0. I don't know, it kind of reminds me of like array index or something like that, and it's the way it's sorting. I don't know, but it's weird. Okay, so what are we doing next? Okay, yeah, we need to work on this guy. So our roughness is going to be the same. So we could come over here to our roughness. Let's grab our little roughness guy. And we could easily just take the output X of this guy and just plug him right into the roughness of our reflection, our next layer of our reflection. So we've done that. Let's go back to our Mia material. We've done that there. We've set our IOR. We just got to do the same stuff. Like, where's our bump? Where are you? There it is. Okay, here's our bump. Let's middle mouse click and drag and place him on here. Our reflection, we're using the same thing. So middle mouse click and drag, reflection. Now, here's, again, something that's really interesting, like I was telling you about before. Now with Substance Painter that we actually can create this converted reflection map. So again, since this is the dielectric section, we want the reflected color just to be white. And so now we can actually export that here with the white in it using just the reflection output. And that's why we're using that. Okay, so next, what am I missing here? We've got that. Okay, so now we need to do the masking part of this. So all I want to do is just use my metal mask again. So here, what I did, and I'll just show you what I did because it's pretty simple. Here's the metallic. I got it selected again. Notice the color space is set to raw. I just created a reverse node. So the reverse node is now just going to just flip that metallic channel for me. And then I take basically, if I look at this guy, output X, and just feed that into layer 0's weight. So let's do that here for our other material. So we'll move this guy up. Let me grab that reverse node and just bring it down here so we can see what I'm doing. So remember, backwards, layer 0 is the one that we just created. Output X, plug it right there into the weight. And that is going to create, you know, the material that we need. So let's see if I can get my IPR to work again. IPR to work again. I think it's going to work. And so basically, yeah, here's what we start to get out of Mental Ray using the Mila shader. It's a close approximation. Like I said, it's not honestly as good as if you were using V-Ray or something like that, just because of the BRDF differences that we have. But you can see that, you know, we get a pretty quick result. I know it's hard to see here in the screen recording, and that I'm trying to use this, you know, proxy render and so on. But if you go to the documentation that we have offline and stuff, you can see that, you know, the examples and everything and how they work differently, or excuse me, how they're working and such. So like I said, it's a little bit of a setup there with the Mila material, but honestly, it's not that bad. You know, once you kind of set it up, you could set it up once and then save yourself out, like, you know, an example scene that it can work with that. And like I said, when you go to the documentation, this demo scene that I've created here, you can download this and see how all this works. So with Mila, the Mila material or Mila material, we just have to separate it up into two different layers. So layer 1 is going to handle metallic, layer 2 is going to handle dielectric, and we're going to use that metal mask metallic map that we export out of Painter just to get these guys to work as a mask between the two. And so that's how you can get that set up there with Mental Ray. All right, so let's make sure we don't save that. Okay, so next, as soon as Maya closes, let's open up Modo and take a look at Modo's workflow. Modo's going crazy on me. Let me see if I can toggle that. There we go. All right, sorry about that. I've got just so many things running at the same time. Everybody's... Okay, So Modo, here what I'm showing is, this is actually 10.1, but everything I'm showing here works in 10 as well. So we're looking at Series 10. And we're going to look at two setups. Number one, Modo has integrated in this really nice, let's see, nope, I don't want to do that. This really nice Unreal material and a Unity material, which makes working with Substance really, really easy, which is awesome. I'm thrilled with it. And what's nice is with the Modo renderer, you can just feed this Unreal material right into like the Modo render. So here you can see, here's what I'm getting out of preview. I mean, it's identical to the V-Ray render. Here's what I'm getting in the advanced viewport as well. So that's pretty awesome too. So you can use the Unreal material if you want to. And I'm going to show you that. And then I'm going to show you another way. Let's say that you don't want to use the Unreal material. You just want to use Modo's default physically based material. So I want to show you that setup as well. That's actually pretty simple. Okay, so first, let's talk about the Unreal material. So if we want to export for the Unreal material, let's jump over into Painter. And let me show you all you'd have to do. So Unreal is going to use PBR workflow, and it uses metallic workflow. So it's going to give you base color, metal, and rough. And the default setup in Painter is base color, metal, rough. So, you know, by default, everything's just synced up very nicely. And what we can do is this. So let's say that, you know, I'm ready to export and I want to work with Modo's Unreal material. Well, since I'm using here under my texture set settings, no, here, let's look at viewer settings. I'm using PBR metal rough. If we notice our texture set settings, my channels again, base color, rough, metal, and so on. I can just export. So right click, export textures, and I can just come over here to my config and I can just choose document channels plus normal and AO. And what this is going to do, and this was a question that showed up a bit earlier here in the comment section. What this is going to do is it's just going to export out whatever document channels I have here. So, you know, if I had emissive or opacity, it's going to spit all that out for me. And that's going to give me exactly what I need for the Unreal material. And it's also going to give me normal and AO. So once we have that set up, we just do our export, and then we just import these guys into Modo. And then create yourself, you know, the material that you have. Underneath add layer, you'll see custom materials, and they have Unity and Unreal. So Unreal is what we're using just to showcase this. Drag my materials, or excuse me, my textures into the shader group here, material group, and then just right click, and then you come over here to, this is the layer effect basically, go to Unreal, and then just for base color, I would choose Unreal base color. And just do that for each one of these textures, and then here's what you'll get right out of the render. So we get something that's matched exactly to the Painter viewport. Modo's render is using GGX as well, so everything syncs up with the BRDF, which is nice. Also, since Modo can create a MICT tangent basis, we're also viewing with the same, and I believe I could check with the Foundry guys to make sure, but I believe they were telling me that the MICT tangents which used by default, I think. But I'll check with those guys to be sure. But you can see that there you get a full, you know, tangent basis sync as well. Now, let's just say that you wanted to also work with Unity. So let me just talk about that just really quickly. So if we were to come over here to export textures, we have a configuration for Unity 5 as well. But you can't use this because what this is doing here, and here's another thing I want to bring up. Oh, you may ask, well, why didn't you just use the Unreal Engine export, which is somewhere in here? Yeah, why didn't you use this? When it comes to our presets that we created for Unreal Engine and Unity, these guys are basically have packed channels, so they are more optimized when you're working inside a real-time engine. So for instance, if we look at Unreal Engine, we created an RGB map, basically an output, and each channel is basically housing a different piece of information. So notice here we've got, I call it occlusion rough metal. This is one that I created myself because I wanted to add occlusion into this. So in the R channel of this map, I've got mixed AO. In the green channel, I have my roughness, and in the blue channel, I have my metallic. I guess you could export these and then inside Modo, you know, just pull out each one of the channels like you would do inside of Unreal Engine. But I just didn't want to. I think it's a pain just to kind of work that way. If I'm just using Modo for rendering and it's not used in the engine at all, it doesn't matter. But if you were using Modo in the actual pipeline, so everything is going to end up in Unreal Engine at the end, you could utilize this packed kind of map workflow. The same maps that you're using inside of Modo for rendering or looking inside the advanced viewport can then be the same maps that you use inside of Unreal Engine. And in these maps, so all your texturing, so basically your modeling was done in Modo and all your texturing was done in Painter. And that's how that would work. I just want to bring that up because if you just use these by default, just be aware that these guys are packed channels. So if I wanted to do a version for using the Unity shader and I didn't want to use the packed channels, I would just have to make a new preset and take my metallic, take my smoothness, and take these things and just put them in individual channels. One last thing to mention on this, smoothness. Unity calls glossiness smoothness, and so really all you need to do is grab this guy right here, glossiness. So that's what that is. Okay, so let's jump back over here to Modo, and that's going to take care of the Unreal material. All right, the last thing we want to talk about is the physically based material. Let's enable this guy. And you'll notice, let me just kind of, force a preview update there. And you'll notice here that, okay, this looks, pretty much the exact same as Unreal. So let's look at what this guy's doing. So if we look at the material here, and we come over to the shading model, notice I've set this to physically based. It's that by default when you create a material inside of Modo. And what we're going to do here is work with some new map outputs. Let me show you what I'm actually doing. So here's what I did. And this right here kind of lets everything come together. I'm using Modo to illustrate this, but this is also really showing the ability in Painter to configure these outputs however you need for whatever render you need. So what I did was I said, okay, I want to do a material. I want to use Modo's physically based material. What are these outputs I have? Well, I've got things like diffuse color, specular. I got a specular amount. I got a specular color. Oh, okay, so I got a cue here from specular amount and specular color, and so on. Okay, so now I got an idea of the maps I want to do. So I come over here to Painter, and I'll create myself a new config. So we'll come over here to configuration, and you'll see that I created a new config that I call Modo PB for physically based. And so I just would create like a channel and then just set my map. So I needed a diffuse texture. And so what I did, since I'm using PBR Metal Rough shader here in Painter, I need to use some of my converted maps. So diffuse is actually this converted diffuse. So I plug that guy in. Notice I'm using reflection, and I'm using the reflection map that we talked about. So that's going to give me the reflectance color for dielectrics, which is going to be white, and it's going to give me the reflectance value for metals, which is going to be tinted. So I'm using that. Modo uses the same roughness as Painter, so 0 is smooth, and 1 white is rough. So no problems there. We can just use roughness. Now, I'm going to utilize the F0 map. This is one that we're using that I had mentioned earlier that's used in the Arnold preset. And so here we have F0, and like I explained to you, what that was is that, well, it's going to be basically metal is going to be white or a 1 value, and the dielectrics are going to give me a specular, an F0 value of 0.04, which again is 4%. Let me jump back over here to Modo, and you'll notice that when you create a Modo material, and it's going to be physically based by default, notice that its specular amount, when you create this, it's at 4%. Okay, so again, that just has to do with physically based workflows in general. Dielectrics are, or I'll say common dielectrics are roughly, most of them are around this 4% reflected value. There are exceptions and so on, but for the most part, 4% is going to get you pretty much there for most dielectric materials that you use. And so look at this, you can see we already have that. Well, we know that our Substance Painter map, like I said earlier, that F0 in the non-metal areas is going to give us that 4%. So perfect. We're going to use F0 for our specular amount. Ambient occlusion. Actually, I'm not using this, so I just had it in there, but I'm not using it. And then my normal is going to be OpenGL. With Modo, you want to export out an OpenGL normal as well, just as we did with Maya. All right, so once we have those guys set up, you can see that I just start plugging everything in. So diffuse is just going to be diffuse color. The F0 map is going to become my specular amount. Roughness is just going to be roughness. And reflection is going to be my specular color. And then normal here is going to be my normal. So that's all the maps that I need to get this to work with Modo's physically based material. Now, just as we talked about with V-Ray and Mental Ray, we're physically based, so we're working in this linear pipeline. We need to make sure that we, have our maps flagged correctly. Now, Modo will try to handle this automatically just like Maya's doing. And I'm kind of an old school Modo guy, so I'm used to using, gamma correction before they implemented that color management system. So I keep finding myself kind of going back to manually tweaking these things. But I am using their new system. I'm not actually going into the gamma node and changing anything. I leave all that be. So it depends on your maps. By default, if we look at what we have here, so if we go to System, Preferences, Rendering, where is that guy? Color Management, I'm sorry. So here's where everything's set up. Float color space, linear, default for 16-bit. You may want this sRGB or linear. It just depends. And then 8-bit sRGB. So basically, I just leave this at the default. Sometimes it tags things right. Sometimes I noticed that it didn't. So what I do is, same rule. If it's color that I see, so my reflection, my diffuse, I need to come over to my image still and make sure that's sRGB. If it's default, now notice I leave it at default. Nothing changes in the render, so default was fine. So you can see there, Modo's color management automatic system caught everything for me fine. I just kind of have, like I said, that old school mentality of just double checking that it's set at sRGB. Roughness, you can see that I did the same thing, linear. What happens if I set this to default? Oh, there you go. Here's a good example. See how it got really shiny all of a sudden? So now my roughness map is not being interpreted correctly. Let's see maybe why that is. Okay, for some reason I've imported this. It's just because I've imported in an RGB 24-bit, and then in my Modo preferences, it's seeing that as 8-bit, so it's like, oh, that's sRGB. I don't want that to be like a 16-bit map or a floating point map at all, so what I'm doing here is that's why I have to manually set that to linear. And when I do that, boom, everything's correct. So it's easy enough to fix. F0 map's going to be the same way. So I set that color space to linear, diffuse, sRGB, and my normal, it's set to none. Usually when you bring your normal map in, Modo, and you set it to normal, Modo, it'll turn off it'll turn this off. You could also switch this over here to linear as well. So see, I'm not getting a change. But if I had this flagged wrong, I set to sRGB, boom, everything gets messed up. So don't color manage it or set it to linear. Either one will work. Okay, so that's all the setup there is there for that. One last thing that I do want to mention that's really important is in your render node here under global illumination, you want to make sure that your environment importance sampling is enabled. And so that's actually working for Mental Ray as well. I closed Maya. I'm sorry, I'm not really super experienced with V-Ray. I think in V-Ray's using importance sampling as well, but in the newest version of Mental Ray, that's enabled, and here it's enabled inside of Modo. That's what we're using inside of Painter as well in our viewport, importance sampling instead of like a MIPT cube map reflection or whatever. Okay, so that's basically everything that I wanted to cover here in today's stream. Let's look at my time. I was thinking I'd try to do it in an hour, but, I can't. I just had to keep it rambling on. There was a lot to cover there, though, so I want to, make sure that we really cover that. So we've got more renderers that we're going to start adding to that documentation and so on. So, like I said, that's been reworked this week. Head over to that documentation, take a look. You can download these sample scenes and so on. Also, I'd just like to mention again that in our forums, if you go to our forums, in the algorithmic section at the top, that we have a section there for the Twitch streams. If you have any questions about this stream, just post in there, and I can, help you there. One question that just came in: any chance Arnold? Yes, we do have Arnold preset. And in case you missed that, let me just jump over here and show you that here. Here's our Arnold preset. I didn't really cover that one today because if you go out to our YouTube channel where we have a video on UDIM workflow stuff that we did for Substance Painter, I think it was the 2.1 release. I'm actually show that working with Arnold right there and how it's hooked up. So we have the Arnold preset. It works perfectly well. It works just like V-Ray. No gotchas or anything like that. It's all just really kind of a smooth process. And like I said, that UDIM workflow on our YouTube channel for 2.1, it shows it working there. One questionnaire link to the docs. Yeah, I can get that going here real quick. Let me just grab it. All right, so here's our documentation that you would find just like when you open up the apps and go to documentation. So it's actually under Substance Painter, miscellaneous, external rendering setup. And also to go with that question, we have Arnold for Maya here in the docs as well. So let me just copy and paste that here into our chat window so you guys have that. Okay, yeah, so like I said, that's pretty much everything I wanted to cover with the stream. As you can see, we're going to keep adding new stuff. If you have any questions, just hit up that forum thread in there, and I'd be happy to help with any questions you have. Also looking at doing some other renderers. I'm going to detail the Marmoset renderer, and also looking at trying to do something with KeyShot. We're talking to the KeyShot guys as well. So, we're going to keep adding more and more of these external rendering support here with Painter, especially as we start to flesh out Painter as well, adding new features and so on. So like I said, the big takeaway is that this configuration window here in Painter is super powerful. You can utilize any of these converted maps to kind of give you, what you need for your render. The most important thing to really take away from that is what this reflection is doing, what this IOR is doing. So again, remember, glossiness squared is used for, if you're trying to match a Blend-Phong BRDF, just square either your roughness or glossiness map, kind of get you in the ballpark there. The IOR map, what that's doing, we talked about that. We talked about reflection. We talked about the F0 map itself, and you saw how that actually related there within Modo and so on. So once you kind of know what these maps do, and you look at your material, like I did there in Modo, and I saw okay, what the material inputs are, it becomes, just kind of a connect the dots kind of workflow there on how to hook things up. And so anyways, that'll pretty much cover everything for this week's stream. So we're going to close everything out. Thank you guys very much, and we'll see you on the next stream. Take care.